514 integrated pest management. How do we get crops? How do we farm our crops without having all the pests eat them? How do we fight back against the pests without poisoning our land? That's the compromise, the decision we're kind of making here with integrated pest management. So we're going to talk about the benefits and drawbacks. Why not just spray everything, right? Just forget about it, spray it. Well, then our environment is harmed. Why not, just get rid of all chemicals? We can go natural. Well, if we do that right now, we won't have enough food to feed everybody. So it's all about a balance. Okay. Feeding people, somewhat economically. It seems like food inflation has really gone through the roof the last 4 or 5 years, and it hasn't gone down, unfortunately. A lot of companies seem to take advantage of the pandemic and are not doing us favors. So we want to use these chemicals and our techniques so we can grow enough food to feed people, but we still have to protect our environment for us and everything in it. Protect our environment. All right. So, we talked about before, California. Farming and agriculture is such a huge business. I believe it was $70 billion. Go back and look at what the actual number was. Strawberries, grapes, rice, tomatoes. Lettuce. We make like 90% of the lettuce in the state, and something like 80% of the country. Numbers are very similar for strawberries. We don't think of California as this big farming place, but it is. Well, not everybody. Some people do. Some people are aware. So let's look at some of the definitions of what we're looking at with integrated pest management, or IPM. Basically, it's a combination of a lot of stuff. Just think about, combination. We're using combination of strategies to control pest species, insects, and other things that eat our crops, while minimizing disruptions. So we don't disrupt our environment, kill too many other insects and creatures that aren't really causing us issues. And lots of different ways we'll talk about. One of them is biological. Wow, my handwriting is a little bit better today. Physical. And limited chemical. In integrated pest management, you might think, well, we don't use chemicals, but we do. There is a time and a place for using chemicals in the right conditions. And there's a bunch of things we'll talk about. Biocontrol is one of them. Biocontrol, using other insects against the ones we're trying to fight. Intercropping, mixing up crops. Crop rotations, don't always grow the same thing. Rotation. And natural predators. Finding the enemy of our enemy. Okay? But want you to think about this is multi-step, data-driven. Just don't go spray everything. We're going to try different things based on the evidence that we find. And that's really what we should do for everything, right? And chemicals are used, yes, but only as a last resort. We want to try everything in our power to avoid chemicals. That's not a first choice in any circumstance. So this might be good. Draw this little pyramid, kind of lays out the priorities here. The first thing we want to do are the least disruptive, and that would be the cultural methods. So just having growing things in the right place. Don't grow things that are going to struggle and you're going to need to put a lot of extra inputs. pesticides, energy, water into growing them there. The right plants to grow in certain areas. Sanitation. Keeping everything clean around the area. If there's a lot of different plants and other things, and growing with our crops, the more likely we'll have pests grow there. And then rotation. I gotta draw right over here. So rotating crops. Rotating crops. Okay, so those are things we have to do with how we farm. And then more physical and mechanical methods. So pruning is a big thing, keeping things pruned. Weeding, I kind of mentioned before, that's kind of part of sanitation, keeping weeds out of there. Mulching, you see that around people's houses, around flower gardens, see mulching. Well, that keeps the weeds down and also can reduce the ability of pests to crawl around on the ground and then come and attack the plants that we are trying to keep, for ourselves. And then barriers, like, putting a fence around something, putting plastic sheeting, blocking the pest from, physically blocking the pest from getting there. And then biological, we can use predators and parasites. Predators, parasites, basically figure out what can kill the animal or the pest we're trying to kill naturally. A natural enemy of our enemy is our friend. You've heard that expression before. And nematodes, little worms that I'll show you in a second. And then we have the chemical methods that are less impactful than the pesticides. So these are kind of some traditional things like soaps and oils. Soaps, oils can be effective. Baking soda can work. And while that's not, that does have some impact, it's not as bad as those very damaging conventional type pesticides that can do a lot of cellular damage to us, or wreck our DNA, or influence our DNA replication, other things. These are all kind of repellents. The ancient Egyptians, like I mentioned before, olive husks, the leftover things of olive oil spread around to kind of destroy or ward off plants from eating their crops. And then the last resort, insecticides, fungicides, herbicides, a lot of sides. Miticides for mites. Let me do that better job on that one. Mites, we'll talk about in a second. It's something that affects us in California here, especially the strawberry crop. Okay, so draw that, increasing toxicity as you see as we go up that pyramid, trying to keep things in this realm, preventing things before they get out of control. And we'll see this all takes some extra effort, and upfront costs can be higher. So here are some examples. Here we see a wasp, a predatory wasp eating this caterpillar. As you know, usually some type of moth. Caterpillars will eat through the crop like nobody's business. Over here, this is we call it a ladybug, but more accurately, landy. Lady beetle. Switch. Uh-oh, what happened? Second. Okay, I figured out how I lost the color for there. Okay, let me just redo this because I had to. Okay, so that's a wasp that's eating the caterpillar. And here we have a ladybug or a lady beetle. Landy. So I got trouble the first time. There we go. And right here, it's eating an aphid. We talked about aphids before. Definitely one of the most common scourges of our agriculture. I remember being a kid on apple orchards and just seeing, aphids all over the branches. And here we have, I mentioned the nematode, a little worm. So the nematodes are crawling into, these would be any kind of an insect in the ground. So in the soil, nematodes would be applied to the soil, and then they'll work their way into the bodies of these caterpillars, and then you see they'll multiply, and before you know it, they'll go belly up. I think I have some other, yeah, here we go. Here's some other methods. Straight up just burning stuff. Just burning. That's an ancient human way to get rid of a problem, right? Burn it. So many. Oh man, thinking about true crime scenes. Criminals burning evidence. Burning. Well, that'll get rid of pests and weeds you don't want. Right here, you're seeing mulch. This right here is mulch. Mulch. Chopped up, usually chopped up bark, some kind of chopped up wood. This looks like straw. Makes it more difficult for weeds. You don't need to apply the pesticides. It also makes it more difficult for insects to crawl in there. And right here, we're looking at straight up traps. I used to work for the USDA. I used to go check these traps for codling moths. So yeah, that was a pest we had up in Washington State for the apple crop and cherry crop. So we were always monitoring codling moths. They use a pheromone to attract the moths in there. We were all just taking care of what's going on. Taking care, monitoring everything. See, if you see a problem before it becomes a big issue, it's a lot easier to deal with. You need to use less intense methods to fix it. And right here, we just see a giant barrier, right? Just put it all inside. You can kind of control the situation, keep out insects, anything else you don't want. So, reducing the risk that pesticides pose to wildlife. And our water supplies. That's a huge thing. What we pour on the ground ends up in the water and can affect our own health. We'll look at a case in a little bit about a school up in Oxnard. There we go. Can't see. There we go. Human health. And here we have birds. Birds are usually or can be pretty sensitive to pesticides. They eat a broad range of things. They eat a lot. So they're bringing in a lot of food, and that pesticide is accumulating, and a lot of times it affects the shell, and the shell isn't thick enough to not crack when the bird sits on it when it's incubating it. So, and birds are, they're eating insects. We're applying pesticides to the insects. And here we know the pesticides have an impact on us. It's tough to study exactly. Humans are so tricky. We're all over the place. We are exposed to a lot of different chemicals. It's really tough to nail down what chemical exactly is causing the issue. But there is good evidence that these conditions, so once you write down a few of these, a lot of neurological things, headaches is very common. Being sick to your stomach. Your liver is a processing organ, helps get toxins out of your blood. So if you have toxins, it's going to take, some damage. Skin and eye, people get terrible rashes. reduced immunity, and that can lead to more cancers if your body can't look out for itself. And then people worry about, miscarriages. Any kind of chemical in the environment can have an impact on us. But there need to be some kind of solid, usually a animal study with rodents to really pin it down to figure out what's causing it. So IPM minimizes disruptions to our environment and threats to human health. So we want it, right? I want you to go cheer. IPM, we need it. But it can be complex. One thing humans don't like sometimes is complexity. We want things simple. I mean, think about it. We kind of want things simplified. IPM is not simple. You got to collect the data. You got to put the effort in. So just let's do some little pros. One thing, reduce chemicals that we're using. Also, we got to be worried about pesticide resistance. If we do need the chemical at some point and they're resistant, then it's not going to be worth anything. So if we can use that chemical less, we're going to lower resistance. And that equals more effective. I'm going to run out of space here, but you'll be okay. more effective pesticides. Okay, so it'll make the pesticides we have even more effective. This will protect beneficial species too, if we do all this. Especially pollinators. We need all of these farms that we apply stuff to rely on pollinators. So if we can help them, we help ourselves. Why don't you write that down? Pollinators. Big one we're talking about, that you hear about, is bees, but there's a lot of others. It can reduce your costs because you're not having to pay for so much chemicals. Long term. Okay. Now the con, it can be costly at first. It takes some upfront investment. Okay. It can be complicated. Slower results. That's another thing. We like things simple. We like things fast. Well, this takes some time. We got to let, you spray chemicals on something, boom, all the insects are dead. But we got to pull away from that and understand long term that's not the most effective thing. So slower results. And it's change. We have trouble with change. Okay. Farmers, how do I put it? They're kind of stuck, can get stuck in their ways like everybody. They're stuck with, I'm gonna write down here. So they're gonna show resistance to change. So we gotta get over that. We gotta act in ways that we can be more effective long term. Now here's a little case study, IPM in action. I've talked multiple times about these strawberry fields we have in Ventura and Santa Barbara counties. They have to deal with mites. So write that down. These are the pests. Mites and fungal diseases usually. So miticides and fungicides is what they're looking at. Fungal diseases, because it can be moist. But if we look here, we can see a couple IPM methods. One very clear is barriers. We see the strawberries growing on top of these plastic sheets, it looks like, and that prevents insects from getting at them. Also, I can't see too clearly here, but I imagine there's drip agriculture going on there. So drip irrigation. So drip irrigation going on to try to reduce the fungal growth. One thing that's not here, they're probably using is sticky traps. That's used a lot. These sticky traps. So to get rid of the insects before they become too much of a big problem. Now, if everything doesn't work, then they will apply a chemical. Okay, but that's the last resort. They'll so remember, for mites, they'll use predatory mites. Hope you can see that red. I think that's it might be hard to see, but I'm saying predatory right there. Let me redo that. So if you have mites, there's actually a predatory mite you can release to kill the mites you don't like. So predatory mites eat pest mites. The mites you don't like get eaten by your mites that don't cause damage, but go after the mites that are causing the damage. So mite on mite. I guess that's mite on mite makes right. Would that be cannibalism? I don't think so. I think they're different species. Here's a fun map. I found this. All the places they grow strawberries commercially in California. And when I saw this, because I've been talking a lot about Oxnard right here on the way to, let me go strawberry color here. Oxnard on the way to Santa Barbara, which is here. And then, oh yeah, I've been to San Luis Obispo a lot lately. Around Santa Maria, there's tons. So I've been going through a lot of strawberry fields lately. But I'm looking here. If you look carefully, look everybody. There is a strawberry field. That's in Long Beach right there. So I'm like, what is this? So I looked into it. This is the Santa Fe Farms, or Santa Fe Strawberries, because that's all they do, strawberries. So the strawberries has been grown in this patch underneath those power lines here along the LA River for decades and decades. 5 or 6 years ago, the family that owned it, the patriarch, he was 85. He died during COVID. He got COVID and died, and then his wife got COVID, and the family just were dealing with that, so they decided to sell it. But they wanted to sell it to somebody who's going to keep it a strawberry farm, so they sold it to these guys, and now it's Santa Fe Strawberries, and you can go there, and I believe they have a stand right outside. I'm going to try to go by there. It's right on 3511 Santa Fe. So Santa Fe isn't too far from here. 1 or 2 streets over from Long Beach Boulevard. Go down south of the 405. You'll see Santa Fe Farms. I thought that was cool. But using IPM methods in California, they've been able to reduce pesticide use while maintaining yields. Now you can see here, this is the producing hectareage and per yield up until 2022, so you can see that increase. Now I wasn't able to find evidence of the pesticide use, so that's an issue. So that's something that I need to find, that we can look for evidence of reduced pesticide use. I didn't find it, but I did come across this article, and it has to do with a high school. I believe it is Oxnard High School, You can see it right here. I'll show you a better picture in a second. But it's located right in the middle of these strawberry fields. And we know that this is a constant theme throughout American life, is that where we find most poisons, we find minority communities, non-white communities. So unfortunately, that's happening here with the strawberry field. Yeah, Costa Mesa High School. There's students really noticed it. They went out to go work out on the track right here, and they're out here running around. Oh yeah, exercising, but then all these pesticides are blowing over. They're applying them and they're wafting over to the high school track. Look, all from all sides, no matter which way the wind is blowing, which I'm not sure which way is the prevailing winds here. If we look back, it's hard to tell here. I'm not sure what north south, but if north is here, they probably be coming from this direction. Oh, and those long fields. So yeah, actually looks like, oh yeah, oh, from this direction. This looks like the ocean probably is this way. Not sure. But they've been trying to, they were definitely not doing full IPM. They were definitely going towards some chemical applications on here. You see on this diagram, they're trying to get rid of something called methyl bromide, but they're using alternatives, as you can see here. Things called organophosphates. And 1,3-D. You don't want to know what that is. 1,3-dichloropropene. As you can imagine, none of that's good to breathe in. So this is still an ongoing issue. I'm going to look more into this. In 2015, there was a lawsuit 10 years ago to try to rectify this issue. But this is, Rio Mesa High School in Oxnard. So overall, IPM, we're looking at evidence. There we go. Evidence, not guesses. And try to do everything else before using chemicals. So just taking your time, trying to work out solutions before you grab the chemicals. All right, hopefully we can rectify the situation and make our environment cleaner. Around Jordan, we have air pollution risks as well, and hopefully we can change the laws. It's all about laws and us demanding our politicians to change those laws. We can affect our environment if we're loud and we get people to act at the state level and the national level.